All right, today you're going to be graphing absolute value equations. Remember that an absolute value represents the distance from 0. We're going to start with the function y equals the absolute value of x. We're going to fill out a table of values. Remember, using a table of values is the least desirable way to graph. If you can remember what you know about transformations, that is easier. When x is -2, the absolute value of -2 is +2. So when x is -2, y equals +2. When x is -1, the absolute value of -1 is +1. When x is 0, the absolute value of 0 is 0. When x is 1, the absolute value of 1 is 1. And when x is 2, the absolute value of 2 is 2. So we are going to plot these ordered pairs, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. When I connect these points, I'm going to connect them with straight lines, remembering to put arrows on the end of my lines. And my lines join in a V. Absolute value functions make a V-shaped graph. And remember this by absolute value makes a V shape. Also, y equals the absolute value of x is the parent function. Y equals the absolute value of x is the parent function for absolute values. Alright, an absolute value function makes a V-shaped graph. What function can you remember is similar to this? Hopefully you thought of the quadratic functions. A quadratic function, x squared, makes a U-shaped graph known as a parabola. We're going to use what we know about quadratics to make our graphing of absolute value equations easier. So I want you to think back to when we graphed quadratic functions before spring break. What are a few things that you know? My first quadratic function, y equals x squared. Well, this is a U-shaped graph. It opens upward. It opens upward because the coefficient in front of x is positive. This is also the parent function of a quadratic. Y equals the absolute value of x y equals the absolute value of x is just like the parabola. The only difference is that instead of a U-shaped graph, it makes a V, but it still opens upward because A is positive. It is the parent function. Let's look at the next quadratic function, y equals x squared minus 2. Minus 2 represents the vertical shift. I have y equals the absolute value of x plus 2. That represents the vertical shift. Y equals 1/2 x squared. The 1/2, the coefficient attached to the x squared, represents a stretch on my parabola. This is going to make it squattier or wider than the parent function. The 1/2 makes it much wider than the parent function. I also have a vertical shift represented. I have a vertical shift down 4 units because of the minus 4. It's very similar to y equals 1/2 times the absolute value of x, close my absolute value, minus 4. This will be wider than the parent with a vertical shift down 4 units. Y equals 5x squared. This is going to be narrower. The 5 makes my graph narrower than the parent function. There is no vertical shift here. This is very similar to y equals 4 times the quantity, the absolute value of x. Again, this would be narrower than the parent function, no vertical shift. What about our next example? Y equals the quantity x plus 2, close parenthesis, the quantity squared. Remember that when we talk about quadratic functions, what happens inside the parenthesis represents the horizontal shift. And remember, what happens inside the parenthesis is opposite. So the plus 2 means I actually move left 2 units. I'm going to move left 2 units. I also have a vertical shift. I have a vertical shift with the number outside of the parenthesis. I'm going to go down 1 unit. This is just like if I had an absolute value, y equals the absolute value of x plus 2, close my absolute value, minus 1. I would, inside the absolute value symbols represents the horizontal shift and its opposite. The number outside the absolute value represents the vertical shift, down 1. So graphing absolute value function works exactly the same way as a quadratic function. We're going to use what we know about the transformations of quadratics and graph these functions without making a table of values. And yes, absolute value functions are symmetrical just like quadratic functions. This is totally awesome. All right, let's start with y equals the absolute value of 2 times, y equals 2 times the absolute value of x. So, when x is 1, y is 2. This is going to be narrower than the parent function. Narrower than the parent function. When x is 2, y is 4. Again, remember that absolute value functions are symmetrical, just like quadratic functions. Absolute value functions are symmetrical, just like quadratic functions. Connect my points with a straight line, putting arrows on the end of it. There you go. The next one. So this graph is going to have a vertical shift. It'll be a V-shaped. It will be V-shaped. So it is V-shaped and it has a vertical shift. We're going to move it down the y-axis. Move it down the y-axis. So I want you to work through these next 3 graphs. See what I've done to show a vertical shift or a horizontal shift. Follow along with the video and fill out your last 3 graphs. Once you've completed this, you have a worksheet after some interactive practice.